All right. Okay. So we will continue with our notes from last time. I have finished about the first part. Okay. Then we will start with the second part. Which you are supposed to have seen this before. This is the very basic of math. Okay, that you will be used no matter what you learn in applied, in pure, in analysis, right? So this is called the methods of proof. I'm sure you have seen this also in the set theory, or there is actually one comment that I go too fast. I thought I did went slow, and because it's a review, but today I will go slow because methods of proof you really need to understand like slower than the one before. Okay. So methods of, if during my presentation you need to say something, you can just unmute and say it, okay? If you are too shy to unmute and say it, you can type in the chat. Nanti Hana or Shiham, you can just interject me anytime. It's okay. Ya, janganlah tunggu sampai ke hujung until berasap-rasap keluar nak tanya simpan kan. You can just explain, or you don't understand, or I say something different. Kadang-kadang saya pun tersasul juga kan. Okay, so methods of proof. The first one is if P, then Q. Okay, you have this statement that you need to prove. If P, then Q. Or before, okay, somebody asked me, not from this class, but from before, whether you use this or sometimes can you write this? It's okay, but be consistent. If you type this in a book or in a thesis, there is the list of symbols, right? But I will use this for this class. If P, then Q, all right? So we have, the first method is called the direct method. The direct method, okay. I will explain in detail. The second one is called contrapositive. Okay, sometimes you were given a statement and then the question is prove this by direct method. Prove this by contrapositive. Prove this by contradiction. If you are given a statement, but you don't have to prove it by certain, they didn't give you, you can use anyone. Okay, anyone that is suitable. Sometimes direct proof cannot be used. I will give you an example after this. Okay, so this is the first one that I want to do for methods of proof. The second one is actually double of the first one. Okay, the second one is P, how do I say it? P if and only if Q. Keluar pula daripada keluar. Right? Macam tu. Now like this. I changed my webcam actually, just use the laptop. I think it's closer. Okay, you will see like this also. P, IFF, if and only if Q. This means this, right? Which bring us to this one, right? Both way. One is this, and then another one is this, right? So you had to do it twice. All right. Okay. I will settle this one first, then we go to the rest. Okay, let's look at the example of the first one. The first one, if P, then Q using All right, method. Okay. So what is the method? Method says that assume P is true, then prove Q is true. Okay, assume P is true, prove Q is true. After this, when you read anything, textbook, notes, if you have to prove something, you look. There has to be a statement. Sometimes, if you read papers, they probably did not mention about the assumption, the assume, but it's there, you have to assume. Okay, now example. Okay. Prove that if X is even, then X squared is even. Okay. Prove that if X is even, then X squared is even. The common mistake that student does is that you try to plug in numbers. Okay, you start with plugging in numbers, right? Okay, X is 2, X squared is 4 even. Then you say X is 6, X squared 36 is even. Okay, so this is true. It's not true. Okay, true for some does not mean true for all. So you have to prove in general. Okay, let me ask this. Why it's not true in? I see Fatana. Fatana, do you like spaghetti?
Yes.
Yes. Alia? Semua suka je lah. Anyone here that does not like spaghetti? Syakir, olok-olok je lah tak suka. Abid, okay, Abid, katalah Abid, you don't like spaghetti, right? So I cannot say, okay, Alia like spaghetti, Fatana like spaghetti, Syakir like spaghetti. Okay, everyone in this discrete class like spaghetti. That's not true, right? Because Abid does not like spaghetti. So you cannot generalize because you never know there will be one particular person or number that does not satisfy. All right, but this statement is true. Not all students like spaghetti, right? So if you want to prove that it is not true, you can just find one person. That's enough. All right, remember this. If you want to show something is true, you need to show in general. If you want to show something is not true, you can just find one example, which we call counter example. That is actually number 3, I think, right? Counter example. Abid is our counter example. Ya ke? Nanti tengok besok ada makan spaghetti. Okay. How do we show this? So, we normally will write proof. Okay, not prove. Silap tu ya. Betulkan in the notes. That's how you put. This is a verb, yeah. This is a noun, proof. Okay, so assume X is even. All right, prove X squared is even. Okay, I want to ask. I ask you once, tadi spaghetti tak kira ya. Then after this I will ask the others ya. Fatana? If I said X is even, what do you know about X is even?
Has a multiple of 2.
Okay, so since X is even, X can be written as 2K, right? K integers. Okay. Saya tipu. Tadi saya kata nak tanya sekali je. Just another one. Fatana. Is 0 an even number?
Yes.
Why?
If it divides by 2, it will
Yeah, 0 is 2 times 0, right? 0 is integer. Strict aja tu soalan bagi macam, ya ke tak ya, kenapa tanya kan? Goyang, dah goyang. 0 is even. Another way to say even number is you can divide by 2. Right? So 0 can divide by 2. Itu kan, takkanlah ni pun tak dapat. If you're not sure, use calculator. 0 over 2. Okay, or 0 is 2 times 0. Okay. Right, then you want to prove x squared is even. Meaning you want to show x squared is also a multiple of 2. Right, because you want to show x squared is even. So then x squared equal 2k squared. Right? You want to put the 2 out, which is equal to 4k squared, which is equal to 2k squared. Okay? So it's 2 times. Now you have to show it's 2 times integer. You cannot just leave it like that. You have to show it's 2 times integer. Now, since k is an integer, ni kertas ni ya. K is an integer. K squared also an integer. Right? 2k squared is also an integer. Ni macam side lah. Kita conteng tepi ya. So, you can let this as equal to m. Saya tengok muka saya sikit. Speaker. Okay, that is clear enough. Okay. All right. Okay, that's good. Okay, so x squared is 2m and m is integer. Don't forget to conclude. Okay, don't forget to conclude. Thus x squared is even, right? Thus, therefore, x squared is even. Okay. If this is clear, can I see your thumb? Ada yang tak jumpa ke reaction button kat bawah tu? I see so many thumbs, all yellow thumbs. Okay, Abid, Farhan, Shakila, okay ya? Okay. Now, if you are okay, then you have to try this. Example 1 just now, yeah? Example 1. Example 2 now. Example 2. Prove that if x is odd, jangan padam you have to rewrite. I can just erase. If x is odd, then x squared is odd. Like, you can think like 1 squared, right? 3 squared, 5 squared. Okay, I give you 3 minutes to write the proof. 3 minutes. Okay. Okay. Next, Akmal, are you here? Memanglah, dah nampak dah tu.
Yeah.
Okay, Akmal, you will help me, ya? Okay. So read it, then I will write. Proof.
Proof X is odd.
Assume X is odd.
X is odd.
Okay, proof.
Proof X squared is odd.
Okay. Since X is
Odd.
odd,
X equal to K plus 1.
X equal to K plus 1.
Integer.
Kita best kan dengan suara kawan ke tidak dengan suara lecturer je kan. At least sekali-sekala mesti rindu kawan-kawan lama tak jumpa. Okay, so
Then X squared equal to bracket 2K plus 1 power of 2.
okay, K
Equal,
in Z. Okay,
equal to 4K squared plus 4K plus 1.
okay. Take out the
Then,
2, right?
yeah, take out 2.
Right? And then plus 1 outside. Because we want to show it's 2M plus 1. Yeah. Tak cukup dah ni macam mana? Okay, I go out here. 2M plus 1. Right? Clear ya? Boleh nampak ya? Okay. This is M ya? So it's 2M plus 1. So say, therefore X squared is
Odd.
odd. You know, sometimes in the book they put this. Do you know what this means? QED? It's normally end of proof. But people sometimes say it quite easily done. It's not. That's how they put at the end of the proof. Or you look at the book, sometimes they put this small box or they put a blackened box. That means it's end of the proof. So after this, if you get to have see a textbook and others, try and look, yeah? Okay, now I go next to, there's additional examples, right? Additional examples that you should try each one. I am not going to do each one here, but in any time in any of our class, if you have a question, you have a problem, you cannot answer, then you can just ask. All right, you can just ask. The first one, if M and N are odd integers, M and N are odd integers, M times N is also odd, like 3 times 5 is 15, right? So you can think now in your mind, okay, M is 2K plus 1, N is, don't use K, okay, don't use both K, right? So the next example is M and odd implies M times N odd. Sometimes you don't write in terms of sentence, but it's in terms of symbols, yeah? So your proof will be, assume, I said I'm not gonna, ni dah tulis dah. Assume M and N are odd, so M is, you can use this, or a different letter. N is 2K2 plus 1. Or you can use 2 different letters, but not the same K because they might be different, yeah? So you multiply. Multiply will be something like this, but K is not the same, right? And then rewrite as 2 times M plus 1. Then that's enough. All right. Let M and N be integers, number 2. If M and N are perfect squares means M is K1 squared, N is K2 squared. Right? Like 4. 4 is a perfect square because 4 is 2 squared. 9. is 3 squared. 25 is 5 squared, and so forth. Then m times n is also a perfect square. It's quite easy, right? You just multiply, take the square outside. Then it's something square. I think it's pretty straightforward. Okay, you can try all. I'm going to go into the second one, which is contrapositive. Okay, contrapositive. All right. Now, for this one, contrapositive means if not Q, then not P. Okay, that is contrapositive. So assume not Q is true. Prove not P is true. I will use the same, not same, but similar question example from before. Example. Okay. If P squared is odd, then P is odd. You cannot prove by direct method, because if you want to prove by direct method, you will write P squared is odd, P squared is 2k plus 1. How do you get P? Square root? Right? You cannot use that. Okay. If P squared is odd, then P is odd. Okay, I'm gonna call the next. Tadi saya panggil siapa? Fatana kan? Okay, okay. Alia Zulkifli. Kita ada Alia Afika, Alia Zulkifli. Alia Zulkifli, I haven't called you today, right? I mean, you don't have to be scared or worried, because if you make mistake, you will remember for the rest of your life. Aku salah jawab lah hari tu. Takkan lupa. Okay, Alia? Okay, can you read me the statement of the contrapositive? Meaning, try to, if not Q, then not P. Can you read that? If
P is even,
not odd dulu lah, sebab kita pakai not kan?
not odd,
Okay.
then P square is not odd.
Okay, great. Okay, now make it better.
If P is even, then P square is even.
Okay. Then this is exactly like our example before, right? So I don't have to show again. It's similar, the same proof. Okay, it's the same proof. Now, from the beginning, you can write by, what is it? Contrapositive. Right? You have that. And then how do you prove is by direct method. This actually is the contrapositive one. But don't worry, up until here is still actually doing contrapositive. But from here, we can just do from before, right? So we assume this, then that. That is actually changing the question to contrapositive and then proving as normal. Okay. I can change this also to if P squared is even, then P is even. Let me do this first. Okay, so now try to change this question to if P squared is Siapa tadi? Alia, can you read for me? If p squared is even,
Then P is even.
even. Okay, can you read the contrapositive?
If P is not even, then P square is not even.
Okay. Okay.
If P is odd, then P square is odd.
Okay. So back to our example before, right? So you just assume P is odd, P is 2k plus 1, and then P squared, just like before. All right, okay. Now I will move on. That's the other example that you can go through because the solution is there. All right. Example 1.32. That is also the same thing, right? If 5 does not divide xy, 5 does not divide x, and 5 does not divide y. Okay, let me show just the question why you cannot use direct method. Yeah, okay. If 5 does not divide xy, this is how you write in terms of symbol. Okay, then 5 does not divide x and 5 does not divide y. Okay, suppose you have to write in terms of symbols containing P, Q, R, right? Containing P, Q, R. Then you will have to write, okay, then you have to write P is 5 does not divide xy, Q 5 does not divide x, R 5 does not divide y. And then this statement becomes P implies Q and R. So sometimes the question asks you to change all two symbols. Okay, so this is what you will do. Now, if you start by direct method, you have to show what? 5 does not divide xy, and then how do you separate? Which is actually a little bit hard. Yeah, Alia Afika now. Alia Afika. Can you read for me the contrapositive? Contrapositive meaning, alah, terpadam pula. P implies Q and R. Can you read for me the contrapositive, okay, using PQR? Okay, let me write here. P. This is the contrapositive for if P then Q. The contrapositive is if not Q, then not P. Right, Alia? Can you read for me the contrapositive for this? Not? If, okay,
if 5 does not
no, you don't have
divide
to read
x,
this. Just read this. Just read this.
if
Not
q, if not q,
then
then not
not.
p.
Solve this first, and then we replace with the statement. Okay? How do you say this? This is not Q, or, right? Or not R implies not P. Right? Okay, now you can read. You can read the sentence.
Not if 5 does not divide x,
There is no does not, because now it's not does not, is divide.
if
Right? This is does not, but not of does not divide is divide. If 5 divides x,
and
or
5
5 divides y,
divide
then
then 5
5
divide
divide
xy.
x.
X.
Okay, you see, this is much easier to prove. Now, this is away from school, right? If you said if 5 divides x, meaning there is a k integer such that 5 times k is x. There is a k2 integer, 5 times k2 is y. So there should be multiply, right? Multiply, then you can show that 5 divides xy. Okay, the rest, you can look at the solution from the notes I'm just giving you. Okay, the third one is by contradiction. By contradiction. This is also very common. To prove by contradiction, meaning contradicting the statement. You have to prove this, but you assume it's not true. Then find a contradiction. If you realize before that you have heard about contradiction, right? Comma, a contradiction. I think I learned it also from form 5. There's somewhere my teacher mentioned about the contradiction. Okay. All right. So now, if P then Q, what is the method? What is the method of the contradiction? Okay. So you have to assume that P is true. You have to assume that P is true, and you have to prove that Q is true. Okay, this is as before, the same as before, but there is a but. But assume that Q is not. Okay, find a contradiction. And this contradiction is normally about the truthfulness of P. Okay, the contradiction is normally will be about the truthfulness of P. We have assumed that P is true. Now we have to show Q is true, but we say Q is false. By that, then we write something, and then suddenly P is not what we assume. Then you put at the end a contradiction, right? Then what does it mean? Since it's a contradiction, then you cannot say Q is not true. Then you will get to show that Q is true. Macam belik-belik kan? It's like putar, but sometimes that is the easiest way to show something. It's very similar actually to contrapositive. Okay, now let's look at again. I mentioned it's very similar to contrapositive. So as an example, as before, okay, n squared is odd, imply n is odd. Okay, now let me call Seni. Seni. All right.
Yes, bro.
Okay, can I see your voice? Can I see your voice? Can I hear you? Say something, I cannot hear you.
Yes, bro.
Okay, that's good. Okay, Seni, how are you?
Oh, good.
Yeah, you already eaten or not? If I ask, how are you feeling? Until lapar. Okay, so now, okay, proof using the method. Using the method, assume. Sini, assume P is true.
Assume n squared is odd.
Okay. Proof.
n is odd.
Okay. But suppose, right? But assume n is even. We have to prove n is odd, but we assume it's the other way around. It's even, right? So try to find a contradiction. If n is even, that is the node of the this. What is this? Then what is n squared? N is 2k, right? And what is n squared? Sini?
4k squared.
Just now, right? N squared 2m is even, right? But you assume n squared is odd. A contradiction. Okay, so this is what I mean by find a contradiction, thus n is odd. Okay, this contradiction is about assuming n is even. So you cannot assume n is even because you assume first. So you just follow through the method. You want to show P, then Q. So you assume P, you have to show Q, but suppose it's not Q, right? Do something and to show that P is a contradiction. Then don't forget to conclude your assumption is wrong, so n is odd. Okay, you can try with another example as before. Okay, now the last part of this, is it the last part? Actually, there's a case by case, but for the case by case, yeah, I had to add. Yeah, Shiham, you help me to add another one. It's case by case. I just did that before. Okay, case by case is like this. Right. Okay. This one is in the notes, yeah? Case by case. So you have like P or Q. Oh, now I changed to capital. P or Q implies R. This is like case by case. Yeah. So what do you have to do? Method is the first one you have to show this, and the second one you have to show this. You remember just now we did very similar with a different example, the does not divide, right? When it becomes contrapositive, actually it becomes the case by case, because I assume the first one 5 divides, the second one 5 divides this, and then to show for this one. So this is a case by case. For example, all right, you have to prove if x equals 1 or x equals 0, then x squared minus x equals 0. Right? Actually, the solution is quite straightforward and simple. We have been doing this without even realizing that this is a method of proof. Okay, so the proof goes like, the first one, if x is 1, then x squared minus x is 1 squared minus 1 is 0. right? The second one is quite straightforward, the counting. If x is 0, thanks, then x squared minus x is 0 squared minus 0 is 0. This is not in the notes. Yeah, I just add this. Supposed to be in the notes about case by case. So straightforward. Meaning you have to assume this one, show this one, and then you have to assume this one, show this one. Okay. Okay, okay. Okay, okay. Okay. All right. Okay, now I go to the last one, yeah? Mathematical conduction. I will just show the basic one. You have to go through all examples and the exercises in the back. Okay, tomorrow I will continue with more examples for this one. And then probably we go and see some of the exercises. We have not seen the exercises. Right. Okay, so you have seen this before. I think it's from school, I remember. And also from the logic class. Okay, given a statement Pn, proof Pn is always true for an natural number, yeah? And natural number that we follow here is 1, 2, 3, ... Some books, some textbook, they start natural number with 0. But normally it's starting from 1, okay? So I just put down the step, but we will continue tomorrow. So you can look ahead, okay? Proof P1 is true. Just plug in k equals 1, step 1, step 2. Assume PK is true. Show PK plus 1 is true. And last part is the same for all. Since P1 is true and PK is true. Oh, sorry, PK plus 1 is true. Then Pn is true for all n. Okay. Since P1 is true and PK plus 1 is true, why this so many is true? PK plus 1 is true, then Pn is true for all n. Okay, just hold with that thought. You can, if you have time from later until tomorrow, but I will continue with the example tomorrow, right, in our class. All right.